I'm so sorry, I kind of left out part B from the earlier video. I just realized it towards the end. Part B is pretty easy. If you think about it, we have to do is find the coefficient of restitution. We know the angle of approach is alpha and the angle of rebound is beta. And then, so for part B, what connects between angle of approach and angle of rebound is, we know tan beta is equal to E times tan alpha, and this is pretty straightforward. All we have to do now is E is equal to tan beta over tan alpha, so that'll be 5 over 12, keep flip change, 4 over 3, so E should be equal to 5 over 9. So that is pretty straightforward when we compare it to part A. For question number 17, we've got a sphere that slides across a horizontal plane towards a smooth vertical wall with a speed of 3v. Okay, so what I like about questions like these ones is it says you have to show that tan alpha is 3, so we know where we're heading towards. So that's a pretty advantage, because you know if you got it right or if you kind of are off somewhere. So we've got a smooth sphere and it is heading towards a smooth vertical wall. So I'm not well, maybe I should have drawn this vertically, but I like to keep it this way. We know the angle is alpha, and then the velocity is 3v. After striking the wall, the sphere moves at right angles to its original direction of motion. So it is gonna move at right angles. So that means this angle now would be, so this is a 90. We know that the entire thing is 180. So these two should now add up to another 90, right? So that means the angle of rebound, or the angle that it is leaving the cushion at, that would be 90 minus alpha. The reason is these two would then add up to 90, and you have the 90. That means you have the complete 180. So, and then that is happening at an angle, with the velocity v. Right. So what do we have to find? We have to show that tan of alpha is equal to 3. Alright. So things that we know that this would then be 3v sine of alpha, and then we also know that the horizontal component, the parallel component, would then be 3v cosine of alpha. So because the horizontal component is the same, this would then be 3v cosine of alpha, but I also know that this is v and the angle here is 90 minus alpha. So if I can use those two informations and connect them, I can say that same parallel component can also be said as v times cosine of 90 minus alpha. So now if we remember our ASTC rule, there's my 90. So if I'm taking 90 minus theta, the sign of that trig ratio would be positive, and if I'm taking 90 minus an angle of cofunctions, this would then become v sine of alpha. So essentially what we have done here is we have kind of established the fact that v sine alpha is the same as 3v cosine of alpha, and now it's pretty obvious. All we have to do now is divide cosine alpha and then divide cosine alpha. The v's and the v's cancel out, so we get tan alpha is equal to 3. So we used the theory that the horizontal or the parallel component gets carried over as it is, and we also used the idea that these are at right angles, so we were able to work out 90 minus alpha and then connect that in this right angle triangle where we use this is v, so the adjacent side would be v 90 minus alpha. So that was part A. Part B, we have to find the coefficient of restitution, so we don't know much. What we know is we know about the angles. So if we don't know much about the angles, what we can do is, because I have a tan alpha here, I am tempted to think of this as my tan beta is E times my tan alpha. And I know what is tan alpha. Tan alpha is 3. Now, beta is 90 minus alpha, so I can think of this as tan of 90 minus alpha is equal to E times 3. And then tan of 90 minus alpha is cot alpha, which is equal to E times 3. If tan alpha is 3, then I can easily work out cot alpha, which is 1/3. So I now have 1/3 equals E times 3, or E is equal to 1/9. Now I think there are other ways of doing this. I can find out that the perpendicular component here would be E times E times 3 V sine alpha. Then I can also say that same perpendicular component would also be equal to V times sine of 90 minus alpha. How did I get that? I got 1 from the idea that the perpendicular component would be timesed by E. The second one is I used this right angle triangle and I said if this is V and that is 90 minus alpha, then this is that. So I was then able to equate both of them together. But then the problem, yeah, I think we will be able to do that one as well. So E times 3V sine alpha is equal to V times sine 90 minus alpha would become cosine alpha. So if I divide the cosine alpha, I can cancel off the v's. I would get E times 3 times tan alpha equals 1. And I know tan alpha is 3, so I can then say 9E is 1, or E is equal to 1/9. So if you want to use that method, you could use that method, or if you want to connect them with the angles, you can connect them with the angles. Both of them would give you the same answer, which is 1/9.